Welcome to the viewers. Now today we discuss the topics of constraints and generalized coordinates and D'Alembert principle finally. Now today at first we are discussing the constant and few ideas of the constants, and subsequently we discuss later the generalized coordinate, and finally we are going to the D'Alembert principle. Now what constant is and what generalized coordinates. At first, if we are giving some of the views, in any physical systems of the particles usually have their coordinates restricted in one or other way. For example, if we are taking the simple pendulum, the position of the bob obeys the equations of the type x square plus y square is equal to L square and y equals to 0, where L is the length of the pendulum, length of the pendulum. Actually, that means length of the pendulum means length of the, specifically length of the string, and motion is confined to the, now we are concept the three-dimensional figure. Actually, motion is confined. Here the equations containing the term x square plus y square equals to L square and y equals to 0, and clear indications y equals to 0 means the axis which is vertical to the xy plane, that the motion is vertical to the, confined to the vertical xy plane. Why these things happen? Because it's some clear indications that x square plus y square equals to L square and y equals to 0. That's why we say this. Now if we are considering another example, the sliding of a block in the greatest flow of the surface, whose equations and the clear equation of the straight line y equals to mx plus c, the rigid body for which the distance of the particle always fixed. And we also considering the sliding of the block on a surface is one while rigid body is fixed. Now let us consider a system of n particle then Newton's law may be written as mi d2r dt2 equals to fi for I equals to 1 to up to n. That means m into, this will be called the accelerations mf, and this will be mf, p equals to mf, the formula, clear formula of Newton's second law. That means 4 equals to mass into acceleration. Here it is accelerations, here it is mass, and this quantity that indicates force. Since each particle may be specified 3 coordinates, actually we are considering 3 coordinate systems here. That means the motion is in space. Then we have in hand clearly 3n coordinates. every coordinate are n, so we are getting 3n coordinates, and this is restricted the equations of constants. That means here how many constants are there. Constants means restrictions, which restrictions we apply. So we have 3n coordinates which may be subjected subjected to, better to say k, and always k is less than equals to thrice n. This is the restrictions. Equations of constants. Now the number of the degrees of freedom, which is the new terms, and that is included in the physics. Degrees of freedom, that is of independent dimensions. Okay, and the degrees of freedom, the is given by small n equals to 3n minus k. That means 3n coordinate system and subtractions of differences between the 3n coordinate systems and subtraction of constants which is subjected to. Now the constant is some kind of restriction of motion of the particle, and the force is responsible for the restrictions are called forces of constants. The force of constants are initially unknown, and that will be required to solve for. So here the restrictions of the forces, and we all get that's a force of constants. And for instance, the tension of the string in the plane pendulum problem is the force of constant, which is determined by solving the equation of motion. If the forces other than the force of constants are designated as applied forces, then this force appeared, and that can be splitted if we are taking it equation number 1. So equation number 1 can be splitted. That means Fi is Fi's are designated as applied forces. Then the equation 1 can be written as mi d2r dt2 equals to Fi is the vector is called applied forces, and another Fi that is called constraint forces for I equals to 1 to dot 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 up to n. Now the generally so here Fi is applied forces and FIC is constraint forces. So generally a constraint is in the form of f of Rj Vj, suppose, and t time is equal to 0 for j equals to 1 to up to n. So it is a take the shape, that means constant is in the form of function of Rj Vj. Three parameters are there. Here it is Rj and Vj will be drj dt and time, that will be 0 for I j equals to 1 to up to n, and where Vj is equivalent to drj dt, that is the velocities of the, that is at the velocities. Now taking it equation number 2. If in equation number 2 t is absent, then we find if t is absent from equation 2, we obtain as f of Rj and Vj. Sorry, here is a correction, here is not t. Actually, if Vj, that means velocity is absent, totally absence of velocities, then we can write f of Rjt equals to 0 for j is equal to 1 to up to n, taking it equation number 3. And this equation is called, that means equation 3 is called another constant, that is called, sorry, another constant, that is called finite or geometric constant. Finite or geometric constraint. And if we are saying which constants for equation number 2, so except from this figure equation number 3, if t is present in the equations, that means it takes the shape in the equation number 2, then these constants are called differential or kinematical constants. So 2 is a differential or kinematical constraint. Now if we are considering a particular class of differential constraints is the linear form, that is a particular case. If we taking the shape of linear form, that is for j equals to 1 to up to n, aj dot vj plus d equals to 0, where if we take equation number 4, where AJ are not all vanishing, and D is a scalar function of, here it is a vector and it is dot product, and V is a, D is scalar function of R and T. So what is happening there? Here is a not all vanishing, and D is a function of R and T. This is a particular classes, and this is called the linear form. There is a differential constant is in the linear form or linear shape. Now if we are taking, if we recall the geometric constant, that means velocity is absent from the equation number 3, and from there in the stationary case, if we are taking del f del t equals to 0, and in the 5 y in d equals to 0, aj are the function of position only. So if we derive another way, in the stationary case, del f del t equals to 0. From equations, here we taking the name of equation number 3, from equation 3. That is, f of velocity is absent, rjt equals to 0, and from here we get del f del t equals to 0. That is the stationary cases. And while if we take it equation number 4, while in 4 if del f del t 0, in 4 we have d equals to 0, and AG are function of position only. So a system is called, now let us conclusion, a system is called sceleronomic if only stationary constraints are present. If it is not like that, that means otherwise we called it as, if there is not present, that means not sceleronomic, we called it as rheonomic. So otherwise we declared it as rheonomic. Now, apart from these general equations of constant, we find another constants that is type of general form, and this type of general form which are called bilateral constants. These are also be unilateral constants which appear the inequality if it will be non-zero. That means bilateral constants are converted to unilateral constant, that is if the terms is non-zero, that means RIVI with the t is greater than equals to 0, taking the equation number 5. But here in the last equation is 4, so it will be equation number 5. And as per examples from this 5, one can think a volume of gas that confined in a box of length ABC. The motion of the gas that is restricted from, if we are taking motion of the gas that is restricted from 0 less than equals to a less than x less than equals to a, and 0 less than equals to y less than equals to b, as well as 0 less than equals to z less than equals to c. Now constant may be further distinguished into two classes. One class is that can be expressed as an algebraic equation involving coordinates. Such constants are called holonomic constants. The corresponding system is called holonomic system. On the other hand, there exists a larger class of constants which are non-integrable in nature and certainly do not expressible as an algebraic equation involving the coordinate. Such constants are classified as non-holonomic constants. So here we get holonomic constants and non-holonomic constants, and the system is subjected them is non-holonomic systems. So now today we end our classes. Thank you.